All right, take a look at your opener here. In 5.5, we learned that triangle inequality theorem. It said that any two sides you add together must be greater than the third side. So taking a look at our sides we can put together then. We can do the 7 plus the 13, and that must be greater than 2x. We can do the 7 plus the 2x, and that must be greater than the 13. And finally, we can do the 13 plus our 2x, and that must be greater than our 7. Okay? So those are our three inequalities that we have to solve. Looking at the first one, 7 plus 13 is 20. 20 is greater than 2x, so we got to divide both sides by 2. So we get 10 is greater than x. In other words, x is less than 10. To solve the next one, we subtract 7 from both sides. So we have 2x is greater than 6, and then we divide by 2. We get x is greater than 3. For our last one, subtract 13 on both sides. We get 2x is greater than negative 6. And then we'll divide by 2. And we get x is greater than negative 3. Looking at our three constraints, only one says x has to be less than something. X must be less than 10. The other two overlap. One says x has to be greater than 3. One says x has to be greater than negative 3. And remember, we want the shortest distance. What is shorter, going from negative 3 to 10 or positive 3 to 10? And your answer is that positive 3 to 10 gives you the shorter span. So there's our set of numbers that we want. Getting into 5.6 then. 5.6 really has two ideas to it. The first one is kind of known as the hinge theorem. And essentially, all your hinge theorem says is that when I look at a triangle compared to a second one, if I have two sets of equal sides, right, I can make a comparison between the included angle and how they relate to their third side. The bigger angle, the bigger the side. Meaning if this angle was 40 degrees, for example, and this angle was 30 degrees, then this side here is the bigger of the missing sides. This side here would be the smaller of the missing sides. Right? And that's really all your hinge theorem is going to say. If two sides of one triangle are congruent to two sides of another, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So what we're looking at here, we need two sets of congruent sides. We got Vx congruent to RT. We got VW congruent to RW. If I have two sets of sides being congruent, then I look at that included angle, 88 and 35. The side opposite the 88 will be bigger than the side opposite the 35. Right? And that is what your hinge theorem says here. So in this case, Wx will be greater than St. We don't know how much greater, but it will be bigger than it. Now, it's going to work the opposite way also. There is a converse to it. We can look at that third set of sides and make a comparison for your angles as well. Starts off the same way. If two sides of one triangle are congruent to two sides of another, and the third side of the first triangle is larger than the third side of the second, then the included angle of the first is larger than the included angle of the second. Essentially saying, if I look at this picture that's here, Once again, we need two sides congruent to two sides. So we got AC congruent to DF. We have CB congruent to FE. Then there'll be a direct relationship between the third sides and the angles that are opposite them. 12 is bigger than 9. So the side opposite 12, angle C, will be bigger or greater than the angle opposite 9, which is angle F. All right, so that's what's known as the hinge theorem. So let's take a look at our example. In example 1, it says given that AD is congruent to BC, how does angle 1 compare to angle 2? So AD with BC, we have one set of congruent sides, but remember, we need two sets of congruent sides for this to work. So these two triangles, it turns out they share your side because of that reflexive property. So I do have two sides related or congruent to two sides. Then there's a direct relationship between the included angles, angle 1 and 2, and their opposite sides, that third side. When we compare those sides, 34 is bigger than 33. So the side opposite 34, which is angle 1, will have to be larger than the angle opposite 33, which was angle 2. So how do they compare? Angle 1 is the larger of the two angles. Angle 1 will be bigger than angle 2. How much bigger, we don't know, but we do know it will be bigger than it. Looking at example 2 then, it says a car leaves a mall. It heads due north for 5 miles and then turns due west for 3 miles. It says car B leaves the same mall, heads due south for 5 miles, and then turns 80 degrees towards the east for 3 miles. It says which car is further away from the mall? When I look at these measurements, we look at our triangle. I got the 3 miles with 3 miles. I got the 5 miles with 5 miles. Then there's a direct relationship between the included angle and the third side versus this included angle and this third side. So the first thing we need to do is figure out those included angles. Looking at the top, the outside angle is 90, so the inside angle is 90 degrees. Looking at the bottom, the outside angle here is 80 degrees, so our inside angle will be 100 degrees. 100 degrees is bigger than 90 degrees. So the side opposite 100 degrees is larger than the side opposite the 90 degrees. So that would have to be my smaller side. So which car is further away? This is my larger distance. So it is car B. All right, brings us to our last idea, what's known as an indirect proof. An indirect proof is when we prove a statement is true by proving that it cannot possibly be false, right? And to do this, you can only use an indirect proof when you have something that's either true or false. There can't be, it could be, or there's a possibility of it being both or neither, right? It can only be one or the other, right? We prove that the opposite is going to be false, right? And there's a 3-part checklist to do this. How to write an indirect proof. Step 1 is identify the statement we want to prove. And then we're going to assume temporarily that that statement is false by assuming that the opposite is true. And here's what we mean by that. If we take a look at our example, it says write an indirect proof that an odd number is not divisible by 4. So we're given x is an odd number. They want us to prove x is not divisible by 4. So step 1, identify what we're trying to prove. That's what we just did. X is not divisible by 4. Assume temporarily that this statement is false by assuming the opposite is true. Well, we're going to assume x is not divisible by 4. The opposite of that is x is divisible by 4. And then it says reason logically until we get a contradiction. Okay, so we're trying to assume we know x is an odd number, and we're assuming that then we're trying to prove that x is divisible by 4. We're going to reason through this and try to see if we come across a contradiction. So x is an odd number. For x to be divisible by 4, that means 4 has to go into it evenly. So x is going to have to equal 4 times something. So we're going to call it 4 times y. Right? For it to be divisible by 4, it has to be 4 times something. Well, if it's 4 times something, that means it's going to have a factor of 2 in it. So I can pull a 2 out of that 4y. So I get 2 times 2y. But we had said it is given that x was an odd number. On the left-hand side here, I have an odd number. On the right-hand side, it has a factor of 2. The only numbers that have factors of 2 are even numbers. So right now, I have an odd number equaling an even number. Can that ever happen? And your answer is no. There is your contradiction. That is what it means to reason until you get a contradiction. So then the last thing to do, once you find that contradiction, is point out that your desired conclusion must be true because the contradiction proves that that assumption was false. Meaning, this has to be false. We just proved that that's false. Well, if that's false, the opposite has to be true. So this has to be true then. That has to be the case. There's no other option. That's why it can only work in a true or false scenario, right? Where it's either yes or no. There's no maybe, there's no sometimes. It's either yes or no. Right? And then here's your homework tonight. The chapter test is not on Tuesday, by the way. Let me get rid of that so there's no confusion there. We will talk in class, though, about when your chapter test will be.